Hi, I'm Debbie with Nixene Publishing, coming to you from the United States, and we're continuing our series on graphene with Adrian Nixon, who comes to us from Yorkshire, England. Hi, Adrian, how are you?
I'm great, Debbie. Good to see you again.
Good to see you too. So we have several things to talk about today, which are really exciting to me. We're going to continue the conversation about concrete because some new research has come out from Australia. And we already know that we've done run the numbers, and using just a little bit of graphene in concrete can reduce 2% of global CO2. Is that right, Adrian?
Yep.
And because of the importance of this, we have a question that we've pulled into this, which is from a Nobel Prize winner, Andre Geim. And he would like to know, is there enough graphite in the world to handle what we need for concrete?
Andre did ask the question of us, but not strictly in this setting. I interviewed him last year, as you well know, Debbie, at the National Graphene Institute, and we were in front of a live audience of about 200 people, and this question came up from Andre. It was sort of answered in the audience, but since then, we've decided to dig into it a little bit more. So I do need to share my screen.
So here's our question from Andre Geim, Nobel Prize winner for graphene. Is there enough graphite in the world to satisfy the demand from concrete and cement production?
Yeah, it's a really good question when you think about it. Not just because he's a Nobel Prize winner, but it's actually quite a clever question, because when you look into how much concrete and cement is produced, concrete, I think, is the second most consumed material in the world after water. Staggering amounts of this stuff are used. So over 4 billion tons of cement are used. That's not concrete, that's just a component of concrete. And that's where the 8% of global CO2 emissions come from. So if we're using just 0.01% of graphene powder, which is made from graphite, by weight of concrete, then you find that you can increase the compressive strength by at least 25%. And Debbie, the work we've already seen from Australia shows that that's an underestimate. It looks like we can easily get 30% increase.
That's really impressive how much more it can actually do, and we're using those conservative numbers.
Exactly, yeah. We want to be on the sort of safe side here, rather than contribute to the hype. This isn't hype. This is real data that's come out of multiple labs around the world. So we know that we can potentially use 25% less concrete, therefore less cement needs to be used, and that's where we get the 2% of global CO2 figure from. So 0.01% of graphene on concrete equates to 0.07% on cement. If we use that 0.07% figure, then of 4 billion, then we come out with about 2.8 million tons of graphene powder required each year. So is there enough graphite in the world to make 2.8 million tons a year? And it turns out, yes. We had a look at global graphite reserves, and all the references are at the bottom of this screen. We reckon that there are at least 800 million tons of graphite in the world, with China being the biggest producing nation. But the answer is yes, there is enough graphite in the world to make graphene to satisfy the demand for concrete and cement production.
And there are other mines around the world other than China. China just has a lot.
Yes, definitely. And as you also pointed out earlier, Debbie, in some other videos, there are other ways of making graphene as well.
Yes, absolutely. So it's like there's going to be all kinds of demand for graphene from all different sectors, but there's ample in the world to take care of this.
Yes.
So what kind of other things are we going to look at to go along with this?
You interviewed James Tour at the Rice University. And Professor Tour has been working on something called flash graphene, and then Forbes asked us to comment on James Tour's work. And basically, he's come up with a way of making graphene from waste, anything containing waste carbon. So you could take waste plastic, 300 million tons a year of waste plastic are produced. and we can stop that going into the oceans and into our fish and into the food chain. All you do is you blitz it with a very sharp electric pulse, which heats the carbon up to 3000 degrees, and that forms the graphene. So we get graphene powder out. And the graphene that's made from this is quite pure and is called turbostratic, meaning that it's quite useful for blending into composites. It is important to make the point that this is research that's just been done this year. It will take probably 5 to 10 years to work its way through to commercial application. This is coming. In the meantime, there is plenty of graphite in the world to satisfy the demand for concrete. And in fact, this type of graphene might end up in more sophisticated composites like polymer composites or other composites which might need very, very pure graphene. So I think, you know, as we've said, Debbie, there is probably, I'll just stop sharing the screen, enough graphite in the world to satisfy the demand for concrete. We're not going to run out of the stuff. There's lots out there.
This is great information, and I think that well, I want to recommend to the viewers that if you haven't done so yet, go on our website to the Graphene World Leaders page of nixenepublishing.com and check out the interview that Adrian did with Andre Geim. And do leave us comments as well. If you have other questions of us, let us know. If you have topics that you'd like us to address, drop us a comment and you'll see the video coming up soon, I'm sure. Thank you so much, Adrian, for your time.
Thanks, Debbie. Good to see you again.